A manned expedition to Mars is a possibility that has everyone thrilled. Even the idea that early humans will visit Mars in the 2030 seconds is speculative. Well, that might be the case. However, it is more difficult than it seems. Given current technological and political tendencies, particularly in the United States, a manned expedition to Mars may remain a pipe dream. Additionally, there are a number of issues over which we have no control. This frequently involves both our bodies and the environment on Mars. Many people, including Elon Musk, who may revolutionize space travel, believe that Mars is trying to kill the first humans to set foot there. We shall nevertheless keep our fingers crossed. Watch till the end to discover all the shocking problems to space travel. 10. Money. A manned Mars mission cannot be funded by NASA. The organization does not receive enough funds from the U.S. government to make NASA's first Mars landing, scheduled for the 2030, a realistic possibility, according to William Gerstenmaier, NASA's chief of human spaceflight, who made this revelation in July 2017. When assessing the cost of a manned voyage to Mars, NASA, private space agencies, and nonprofit organizations provide wildly divergent estimates. This ranges from $100 billion spread over 40 years to $1 trillion spread over 25 years. NASA, however, cannot afford to use their assessment. $19.5 billion was allocated to NASA for the 2017 fiscal year, until we discovered that the organization divides this money among a number of space missions, initiatives, and research. The sum appears like a lot, given the way things are going. NASA's lack of money is not expected to end anytime soon. In recent years, its budget has barely expanded by a pitiful 2% annually. 9. Loneliness. Humans are social beings that frequently need interaction. This might become a concern during a mission to Mars, according to researchers. A few years ago, researchers made a group of people spend a sizable amount of time in a remote habitat in the Arizona desert. They observed that some people experienced melancholy and mood changes quickly. Others turned antagonistic and, for the most part, stopped communicating for 18 months. When they did communicate, it was only for quick discussions about running the facility. The team afterwards had psychiatrists available to them. But astronauts on Mars won't have the same luxury. Some scholars now doubt the wisdom of sending just 2 astronauts to Mars in a single spaceship in light of the test findings. The astronauts may meet their end because they will likely grow bored, despondent, and possibly even develop to loathe one another. However, some studies believe that if the 2 astronauts have compatible personalities, this is unlikely to occur. 8. The Dust Storm. A 90-day expedition by NASA's Opportunity space rover to look for signs of water on the red planet began in January 2004. Opportunity almost promptly finished the task at hand and went on to execute other missions over the next 15 years. When it lost touch with NASA after a dust storm in June 2018, its improbable survival streak came to an end. Due to its need on solar energy, Opportunity frequently hibernated at night. But as the storm's dust covered its solar panels, it probably turned to its backup batteries. Opportunity was powered by batteries until they ran out. NASA is concerned that the solar-powered stations the astronauts use on Mars may have a repeat event. There are 2 distinct types of dust storms on Mars. The first and most frequent are the recurrent storms, which have the potential to engulf vast areas of land as large as a whole continent on Earth. Fortunately, these storms are brief and weak, lasting only a few weeks. The other is a stronger but less frequent global dust storm that covers the entire planet, like the one that destroyed Opportunity. Every 5.5 Earth years, there are large-scale dust storms that can continue for months. They might also shield Mars from sunlight, endangering the stations and the astronauts, in addition to covering the solar panels. Thankfully, the stations are unlikely to sustain significant physical damage from Mars dust storms, despite their name. They are more like a breeze than a storm. 7. Food. The Massachusetts Institute of Technology PhD students conducted a study that suggested a human colony on Mars might perish from malnutrition. The study's foundation was Mars One's proposed manned mission. By 2025, the organization hopes to establish a 40-person human colony on Mars. Crops raised inside the colonists' habitat will supply food. The astronauts will have to decide between having enough food or oxygen, according to a mid-research simulating that environment. Plants create oxygen as a byproduct, which explains why the habitat's food and oxygen levels are related. That oxygen will be utilized to keep the astronauts alive on Mars. According to the mid-study, if the plants generate enough food to nourish everyone in the ecosystem, they will produce too much oxygen. The astronauts' lives will undoubtedly suffer as a result because breathing too much oxygen can be fatal. If the plants produce less food, which would not be enough to feed everyone, the oxygen levels would be balanced. According to the researchers, this issue might be resolved by creating an oxygen removal system, which is not currently in existence. 6. Spacecraft. NASA, SpaceX, and Blue Origin are now in the lead in the race to put a person on Mars. In actuality, all three groups already possess spacecraft that are capable of bringing humans to Mars. However, from the perspective of human safety, their rockets employ hazardous fuels and would take too long to reach Mars. By creating the Space Launch System, which burns liquid hydrogen and other chemicals as fuel, NASA is attempting to address this issue. While Blue Origin is content with using liquid hydrogen as its spacecraft's fuel, SpaceX is exploring making modifications to use liquid methane. Some people continue to question if these new spacecraft and fuels will enable us to reach Mars. One is former NASA astronaut Chris Hadfield, who compared getting to Mars in even the newest spacecraft under development to paddling across an ocean in a canoe. Hadfield thinks that the risks of space travel and the unpredictable nature of spacecraft will claim the lives of the majority of astronauts long before they touch down on Mars. Curiously, Elon Musk, the CEO of SpaceX, concurs, having previously said that the first manned expedition to Mars will likely result in fatalities. If you are finding the video informative, smash the subscribe button, leave a like and comment on what you think at the end of the video. 5. Surgery. As the likelihood of lengthy manned space journeys to the moon and maybe Mars increases, researchers are beginning to consider the challenges involved in doing surgery in space. Because of the unusual conditions in space, unwell astronauts are more likely to pass away from small wounds and infections there than they would be on Earth. Injection administration, wound sewing, and even tooth extraction are common medical tasks that astronauts traveling to the International Space Station are trained to handle. However, if they experience more serious medical problems, they would need to immediately return to Earth on a spaceship that is permanently docked at the ISS. This is so because the ISS's sickbay is little more than a first aid kit. Even if the sickbay met hospital standards and had a permanent doctor, which it does not, the absence of gravity would provide a significant obstacle. Blood from the wound or surgical incision could float and block the doctor's eyesight, among other issues. Even worse, it might infect the entire cabin. The astronaut will experience a great deal of pain because anesthetic does not function as well as it does on Earth. Long-term missions to the moon and Mars may make these issues worse. Use of robot surgeons under the real-time control of human doctors on Earth is one suggestion. While this would be feasible on the moon, it would be impossible on Mars because it takes 20 minutes for information to get from Mars to Earth, and vice versa. 4. Mars toxic dust. A manned expedition to Mars could be hampered by the poisonous dust that covers the planet. Round, fine, electrically charged silicate particles that make up Mars dust will adhere to human spacesuits. Since the dust will be challenging to clear, there are worries that it may enter the astronauts' base and clog vital equipment and systems, including as water purifiers and air filters. Because the tiny silicate particles may find their way into the lungs and mix with the water there to create dangerous compounds. This might be fatal. When we learn that the dust also contains gypsum and perchlorates, the effect is exacerbated. Gypsum itself is not harmful, but prolonged contact can have negative effects on the skin, eyes, and lungs. Thyroid gland issues could result from perchlorates. 3. Exposure to space elements. Cosmic rays and erratic solar storms are abundant in space and can produce strong radiation. According to scientists, radiation exposure for humans going to Mars could be up to 20% higher than what they would experience on Earth. This powerful radiation may result in neurological diseases, cancer, heart, lung, and eye issues. Given that a one-way voyage to Mars could take 6 months, this could be a serious issue. The situation is made worse by the unexpected nature of solar storms. Making a spacecraft that could transport men to Mars far more quickly is one solution. Even when they reach Mars, astronauts still face these radiation threats. Although the atmosphere of Earth protects humans from harmful radiation, the atmosphere of Mars does not. The solution put out by scientists is to wrap the Martian housing for humans in a strong anti-solar storm material, similar to the shielding seen on some ISS components. Others contend that by relocating humanity to one of Mars' countless lava tube tunnels, they will be shielded from the radiation. 2. Our bodies cannot cope. The near-zero gravity conditions found on the ISS are difficult for human bodies to adapt to. A voyage to distant Mars would make this worse both during and after the trip. On a mission to Mars, astronauts would have to contend with 3 separate gravitational forces. Before and after their journey, astronauts will encounter the first gravitational field on Earth. The one we are accustomed to is this one. The astronauts' experience of zero gravity as they fly between Earth, and Mars is the second. The third is Mars's gravitational field, which is just 1/3 as strong as Earth's. Our feelings of balance and movement are distorted as we move between gravity fields. Our ability to coordinate our eyes, heads, and hands is also impacted. affected. Hell, astronauts will lose significant bone density as a result of the reduced gravity levels outside of Earth. Because of this, they will likely break their bones upon landing on Earth. Body fluids will also leak into the skull due to the reduced gravity outside of the Earth. Numerous issues, such as kidney stones, dehydration, calcium loss, and vision issues, could result from this. If drugs didn't behave differently in space, their effects would have been lessened. 1. The return trip. Because astronauts who travel to Mars won't be able to return to Earth using existing technology, an expedition there will be a one-way trip. Although NASA is already working on the Mars ascent vehicle to enable a return journey, the technology has certain issues of its own. When finished, the MAV will weigh 18 tons and have 33 tons of additional fuel for Mars takeoff. Due of its enormous weight, the MAV will be impossible to safely land on Mars because of the planet's thin atmosphere, which could cause it to burn up or cause it to crash into the ground. The Curiosity rover, which weighs just 1 ton, is the heaviest object we have yet placed on Mars. NASA plans to address this by making the MAV lighter and creating an inflatable heat shield that will reduce the craft's speed as it approaches Mars. The MAV's interior will be extremely simple, and it may not even have seats. The astronauts won't be walking all the way back to Earth, though the Earth return vehicle, which will orbit Mars and bring them back to Earth, will be used to transfer them. The ERV was also developed in order to lose weight. NASA will build a 2-part system made up of the MAV and the ERV instead of a single spaceship that will launch from Mars and transport the passengers back to Earth. The astronauts will be taken by the MAV from the surface of Mars to the ERV, which will return them to Earth. By having the MAV produce its fuel from the atmosphere of Mars, scientists will also minimize the weight of the vehicle. The MAV will mine the plentiful carbon dioxide in Mars' atmosphere and subsurface water for the methane and oxygen it needs to generate its fuel. Subscribe for more.